everyone. So today we're doing a quick review of integers and some of the properties of algebra. So we talked a little bit on Friday in some of the classes about some of the properties, but I think in one class we didn't get to it. So let's just quickly review. The commutative property of equality basically has two parts for both addition and multiplication. And I'm going to go over these in class as well. But the commutative property basically says that if A plus B equals B plus A, then I'm basically allowed to flip things around if it's going to help me add them together. So for example, if I do 2 plus 3, I also could do 3 plus 2. And when we get into adding and subtracting integers, I'm going to really show you where you're actually using it and may not even realize it. The same thing is true for multiplication. The property says A times B is equal to the same thing as B times A. So for multiplication and the commutative property, 6 times 4 gives me the same result as 4 times 6. All right, so these are some really important properties that we have to be able to identify we're using because they're allowing us to do some of the math that we do in our head. Okay, the associative property. The associative property basically says under addition that we're allowed to associate or group different things together as long as it's under addition, and the same thing with multiplication. So it basically says if we have something like A plus B, a quantity, meaning in parentheses, plus C, that we could actually regroup this around with the parentheses and say A plus B and C. Sometimes I don't want you to think of it like this. Sometimes you want to add numbers differently than the parentheses are telling you to. Well, as long as it's under addition, the associative property allows you to do that. The same thing is true with multiplication. AB times C is the same thing as A times B times C. Again, it's just letting you group things differently. And this is somewhat part of the order of operations, but it's making some changes to it as long as we're dealing with addition and multiplication. So example might be 5 plus 6 plus 4. The 5 and 6 are in parentheses. Well, you may choose to actually add the 6 and the 4 together instead. So what you're actually doing is this, because that's a nice number giving you 10. Same thing with something like this, 12 times 7 times 5. The parentheses are around 12 and 7, I might use the associative property because I know that 7 times 5 is an easy number to multiply. So I could move those around. Now, we are doing this, but we always have to be able to explain why we're allowed to do something. Okay, the reflexive property. The reflexive property I really like, and we spend a lot of time using it in geometry. But the property says A equals A, or anything equals itself. All right. I like to think of the reflexive property when I've actually solved equations. Sometimes you solve an equation and you end up getting that, okay? 2 does equal 2, so it's a true statement. But if you were to get 2 equals 3, 2 equals 3 is not a true statement, so it would be no solution. So it's because it's not reflexive, because the answers on the left don't equal the answers on the right. So I actually really love this property for helping me check myself and making sure that my equation makes sense. A couple more. The symmetric property. The symmetric property basically just tells us that we're allowed to look at things slightly different or backwards. So if I say A equals B, well then B could also equal A. You know, sometimes in class you'll see a student, they'll write this, 2 plus X. It really is the same thing as X plus 2. Oops, I just used the commutative property. I made a mistake. I'm sorry. How about, what did I put here? 2x plus 5 equals 6. It really is the same thing as 6 equals 2x plus 5. Okay? Making sure that you guys understand that. Sorry about my little mistake. The transitive property. The transitive property allows us to connect things. So we use the transitive property actually a lot in geometry. Next year when you're doing geometry, you're going to be doing these wonderful things called proofs, and it's a step-by-step process of why things happen or why things are true. So you're connecting step over step together to get to a final result. The transitive property is really great like that. Transitive property basically says if A equals B and B equals C, well then A equals C. Let's use it with numbers. What about if X equals -3 and -3 equals P? Well, you connect, they both equal -3, so therefore X equals P. It's a way to connect a couple of things that are equal to the same thing, okay? So those are the properties, and like I said, we are going to spend some time going over them some more, and I'm also going to be talking about the property that I've been talking about since the first week, substitution, my favorite property around, putting one value into an equation or substituting it into an equation. Every time we evaluate, we're really kind of using substitution. All right. Integers, onto integers. You spent a lot of time in pre-algebra practicing your operations on integers. So an integer that integers that are things that we talked about, are adding and subtracting integers, is positive and negative whole numbers. Now, the rules on integers, positive and negative numbers, apply to everything. They apply to fractions, they apply to decimals. So let's look at this. I have a -9 and a +11. So you've learned that the bigger the number, okay, the negative plus a positive, so we call this the -9, this is a +11, is going to yield a +2. All right, looking at the next one, we have -9 minus 11. So I know now, since they're both negative, my number is going to be more negative. So -20. -9 minus -11. Well, I know that you learned that if you see a negative and a negative, it becomes a positive. So we're back to -9 plus 11, which is 2. +9 minus 11, okay, so we know that that 11 is taking, is more negative than the +9, so we end up getting -2. All right, and then we have a +9 minus -11. Remember, we see negative, negative, we should change it to a positive, and 9 plus 11 is 20. Now that's 1, 2, 3, 4, 5 ways that I can do an operation with the number 9 and 11 with positive and negative numbers. It can get very confusing when the problems start to get more involved. I go through some rules, and your teacher may have used these rules last year. I'm actually going to get out of full screen really quickly so I can scroll. But the rules that I have always used is that if the numbers have the same signs, then add the numbers and keep the sign of the larger numbers absolute value. And usually what I'll say, instead of saying the larger number's absolute value, is I'll keep the sign of the larger number, but disregard the sign. All right, if they're different signs, you subtract the numbers. Subtract the numbers. And you keep the sign of the larger number's absolute value. Absolute value. All right, so I didn't put an example there. Let's look at an example. All right, so if I give you -2 minus 6, the sign of 2 is negative, the sign of -6 is negative. So they are the same signs. So same signs, what do? Same signs, we add. So I'm going to add 6 and 2, and I get 8. The larger number, so this one, 6 is larger than 2, is negative, so my answer is -8, okay? Whereas if I do -2 plus 6, they are different signs, so we subtract the numbers. 6 minus 2 gives me 4. We keep the sign of the larger number. The larger number, just the 6 and the 2, or the larger number's absolute value, is positive, so my answer would just be 4. Same signs add, different signs subtract. Same signs add, different signs subtract, okay? All right, let's look at a few examples. Oh, and then I want to go over opposite of a quantity. I've been talking about this word quantity a little bit. Let me just see how we're doing on time. Quantity means something that is in parentheses. Quantity means something in parentheses. So if I want the opposite of something, I put a negative in front of it. So that's telling me I want the opposite of this quantity. So you have to remember that if you want the opposite of a quantity or a negative of a quantity, you have to change the sign of everything within the parentheses. So this would become -x minus 2. You change everything inside to its opposite. All right, another quantity. I have a negative, so I want the opposite of a quantity. So this would become negative y. You take the opposite of negative 2, which becomes positive 2. I always like to say it's like distributing the negative, okay? All right, now I've got, made it a little bit harder, I've got a 4 out here. This means 4 minus this entire quantity. That 4 doesn't mean I'm multiplying it. So you still have to deal with taking the opposite of the quantity. So it would be 4.
Lightning alarm.
I want to change the sign of P. There's that lightning alarm. And then I want to change the sign of 6. So plus 6. Now this one I'm allowed to add the numbers and I would get 4 plus P plus 6, which would give me P plus 10.
Warning, lightning alarm. Seek shelter.
Seek shelter. Okay, we know that lightning alarm's working. All right, moving on, let's practice. Now look what I did. I gave you all this crazy stuff, and now I want you to try and put it all together. I gave you all these properties you're allowed to use, and now I've given you all these negatives and positives. So basically, the commutative property says I'm allowed to flip things around a little bit. So what I like to do is I like to look at all my, let me switch colors. I like to look at all my positive numbers. Actually, 0 is nothing, so I'm going to get rid of that. So I've got 46 and 18. 46 and 18 is going to give me 64. So I'm going to use the commutative property and pull this one over here and add them, and I get 64. Now, I have a negative 33, a negative 93, a negative 2, and a negative 34. So they are same signs. They're all the same signs. Same signs, we add the number, and we're going to keep the sign of the larger number. 93 is the larger number, so it's got a negative in front of it. So I know that I'm going to be subtracting some number. So I'm going to add 93, 33, 2, and 34. Okay, I worked that out, I think, and I think that comes out to be 162. All right. So now I've got 64, a positive number, minus 162. So different signs, we subtract the numbers, and we keep the sign of the larger number's absolute value, the absolute value of the larger number. So I'm going to do 162 minus 64, which is what, 98? Okay? But because 162 is the larger number and its sign is negative, my answer is going to be negative. So negative 98. You with me? I used the commutative property there a couple of times. All right. Now I threw some parentheses in it for you on brackets. Order of operations still applies. We have to do everything we can within the parentheses. So here I saw 24 minus 5. We keep that negative on the outside and make that 19, okay? Plus, I've got to do these parentheses and I get negative 2 plus 6, which gives me 4. Because they're different signs, we subtract the numbers and we keep the sign of the larger number. All right, now I want the opposite of a positive 4, which is negative 4. Okay? And then the opposite of 19, which is negative 19. Now, this plus is right here, but because I had a plus times a minus, these still give me a negative. What actually is saying is this, negative 19 plus negative 4. These are the same signs, so indeed we add the number and we get negative 23. You with me so far? Okay, I want you to look at 3a minus 7 plus 4b minus 6 and try it. All right, so we had 3a minus 7 plus 4b minus 6. Well, first of all, I know you learned last year you can't add these guys because they don't have the same variable. They're not like terms. So I'm going to put them by themselves. But I can move negative 6 and negative 7 next to each other using the commutative property, right? I can flip things around. It's really kind of the associative property in ways too sometimes. All right, negative 7 minus 6 becomes, they're the same signs, we add the numbers, and we keep the sign of the larger number. And so we get 3a plus 4b minus 13. Okay, one more. Now I told you that this also works with, so we're going to jump to the fraction. This also works with fractions. Now, I look at the fractions right away and I say to myself, well, they're both negative. So if it's the same signs, we add the numbers. So I'm going to add 3 and 2/5 plus 1 and 4/5. I'm going to pretend those negatives aren't there because I just think it's easier for me. So 3 plus 1 is 4. 2 and 4 is 6, so I get 4 and 6/5. 6/5 I have to simplify to 1 and 1/5. So 4 plus 1 and 1/5 gives me 5 and 1/5. Okay, but now both of these were negative, so we keep the sign of the larger number as absolute value. So 3 is the larger number, so it is negative, so my answer is going to be negative. Same signs add, different signs subtract. All right, what I'd like you guys to do is on the next page, I'd like you to go through A through D and then A through G. Bring your answers in tomorrow and let's see if you really feel comfortable adding and subtracting integers. But I will say, I want you to remember when you evaluate, make sure when you plug something in, you put that value in parentheses, because now these negatives and positives are really going to come into play, okay? All right, I hope you guys have a great weekend. I'll see you on Monday.